All right, so put your headphones on just to make sure you can hear me. It's very weird not to hear myself through the speakers. So let me welcome everyone and just say that I'm very happy to see all of you here, because to me that just proves that the grant system works. So if you think about it, all the way up from London transportation systems to this venue's logistics, logistics at the check-in, our event app, all those things, they work together, they work in symphony to make sure that you get safely and reliably from your home, from your hotel, to this room, and you can enjoy the event and get the value that you're looking for today. Now, imagine something unexpected happen. So imagine there's some bad actor and they want to sabotage this event. So say there's the football game going on right now in London, and that abusive actor basically puts up the signs all across London saying, to the stadium, go this way. However, all those signs, they point to this venue. So what is likely going to happen for you, if that happened, is that you would stumble into those massive crowd of misdirected football fans at some point, effectively denying you accessing the service that should get you here. And in a very same way, DDoS attacks can also affect your application. And that is when abusive actors are able to orchestrate huge wave of traffic, unwanted traffic, towards your infrastructure or application resources, to the point where there's no room left to serve your legitimate users. So this session is all about what we can do together, we as AWS, you as the customers, to prevent that from happening and make sure that DDoS attacks don't bring down your application. My name is Kamil Bogacz, I'm a solution architect here at AWS, and I'm also very pleased to share this session, share the stage with Sean McCune and Harry Carr from Chatwood Financials, who will also share their story and what are some blind spots of DDoS that they were able to identify, and how they evolved from this to the point where they manage and govern their DDoS controls at the wide organizational scale. All right, let's hop in. To give you a better idea what's going to happen in the next 45 minutes, there are three big parts of this presentation. In the first one, we will explore the DDoS landscape from AWS point of view. So the scale at which those DDoS attacks continues to reoccur, and what are the trends in terms of form of those attacks, as all those things, they do shape and inform the strategies and mitigations that we deploy and put in place. Then we will go into some more details. What are those key strategies and defenses that we put in place to protect AWS infrastructure and services? These are those infrastructure and services that you use to build your workload, so you benefit from all of those activities. And then in the last part, we will turn attention to you and the things that you should do to adapt best practice and recommendation to build DDoS resilient application yourself. Now, as far as leveling go, this is 200 level session, so this is a technical session, yes, but we're not going to go into a great deal of these details on any of those topics. The idea is more to give you like holistic overview, and then you can dive into those topics at your own convenience. All right, so let's start off with taking a look how we see DDoS attacks as they're coming our way. And I guess it shouldn't come as a surprise when I say that AWS gets a lot and sees a lot of DDoS attacks. And this simply stems from the fact that we do host a sizable chunk of online applications out there. So simply by the laws of internet gravity, we do attract a lot of traffic. Part of that traffic is a bad incoming traffic, including DDoS attack as well. And the scale at which we deal with that attack is really unprecedented. As you can see over here, we are talking about more than 500,000 DDoS events every year that we need to face. And this is really a tangible evidence to all of you that DDoS threats is an imminent part of the internet. And if you run any public-facing applications, it's more likely than not that at some point you will have to confront DDoS attack yourself. And the question is, are you prepared? So while this graph shows the scale at which we have to deal with those attacks, it doesn't reveal any changing trend yet. So where this gets interesting is once we break down all those DDoS events into attack categories. Starting with infrastructure layer attacks. So this is the most traditional type of attacks which has been out there for many, many years. This type of infrastructure level attacks, they tend to leverage some of the pre-existing flaws or imperfections of the protocols that we use up until today. So all those protocols, they still power protocol stack that we run over the internet. So those attacks, these were not necessarily very sophisticated type of attacks. They were not very difficult to execute, as they exploited the disparity between the resources needed for the attacker to send the request and then the resources needed on the victim side to handle that resulting traffic. So more precisely, we're talking here about attackers who used amplification factor between the requests and responses. For example, in DNS amplification attack, where the response is magnitude bigger than the actual request, and it sends to the victim because you spoof their address in the first place. Those attacks, they can also take advantage of stateful nature of those protocols, which can lead to resource strain on the server side when those servers are consumed by all those bogus requests that are receiving, which intend to open the connection, keep the connection open, but attacker has no actual intention to use those connections in any meaningful way. They just ties up your resources. As you can see, those type of attack, infrastructure layer attack, they are on the declining trajectory. And the reason being is that they are pretty well-known type of attack vectors for which we have developed and industry developed pretty effective heuristic and mitigations to deal with those. So to execute such a successful attack as such, it takes much more efforts for the attackers. Now, conversely, we see the reverse trend with the application layer attack. So now to put it very simply what those usually manifest themselves as the large volumes of well-informed HTTP requests for web application, because the web application is the most prevalent type of workloads that our customer run for public-facing application. So those attacks, they don't exploit any particular flaw or vulnerability of their underlying protocols. Instead, and for that reason, they just look like any normal traffic. So they're very difficult to distinguish what's the legitimate traffic and what is the attack. So for that, you would usually need to deploy some anomaly-based detection, where you look for the suspicious anomalous traffic patterns that strongly deviate from your baseline and take the right action to identify attack vector and shut it down. So this trend is strong and well-grounded in numbers, as we now see more than 50% of the attacks are application level attacks. And that keeps growing at 40% year-over-year rate. And those numbers, more than anything, they're really call to action for you. Because as you're going to learn in a little bit, all the mitigations that are targeting the application level attacks, they don't happen without your active participation and involvement in setting up those defenses and in setting up right mitigations as you see the fit for your application. So now that you know how the landscape looks like, what are the emerging threats, let's unpack what AWS does to stay on top of this large scale of attacks. Starting with what we do to protect our AWS infrastructure and services that run on this infrastructure. So first and foremost, the thing that we do, we run our default mitigation at the border of AWS network. So those mitigations, they scrap incoming inbound traffic. And you can think of those mitigation as firewall-alike type of rules, which either block, they rate limit incoming requests based on the properties at the network or transport layer. However, what is unique about this mitigation in AWS is that we don't protect just arbitrary target IPs. We know exactly what is the service behind those IPs. So from the context of what is the service that we're protecting, we can also infer and create more stringent mitigation rules to eliminate more of that bad traffic, excessive traffic. So let me give you a concrete example here. Whenever the inbound traffic comes in against CloudFront, Amazon CloudFront IPs, which is AWS Content Delivery Network, from a high-level perspective, what CDN is a highly distributed HTTP proxy service, which runs only on the ports 80 and 443. So any other traffic can be considered noise, and can be blocked at the border of the network before any of that requests engage CloudFront resources. In a similar fashion, we can also put other generic mitigations. For example, block all the traffic which pretends to be coming from AWS network at the border of the network. Because we are AWS, so we know that our internal traffic is not coming from the border network, and it's actually carried deeper in our infrastructure. Now, doubling down on that concept of, hey, let's infer mitigation rules from the context of the service, we can also do that to remediate some of the protocol abuse activities. So let's take now Amazon Route 53, which is our managed DNS service. So since we have been running this global DNS service for many years, we already know what good traffic looks like, right? And over the years, we know that most of the DNS queries are coming from well-known and pretty stable resolvers which are homed into ISP's network. So these are trustworthy sources of the incoming DNS queries. So having that visibility and insight, we can now build packet suspicion scoring system. And whenever any Route 53 location is at capacity, we can score each incoming request with the suspicion score and give all the bandwidth, all the capacity it's needed for the traffic coming from those trusted resolvers, whereas for traffic coming from not so trustworthy resolvers, which, for example, just showed up, we can rate limit them properly to make sure that every Route 53 location always doesn't receive more traffic that it can handle. And that's one of the factors which allows us to provide 100% SLA on Route 53. Now, unfortunately, besides external threats, there are also some other attacks that originate from within AWS as well. And this usually happens through some kind of instances which have been infected by malware. So we are not blind to these threats neither, and we run our monitoring system to identify those instances and make sure that we isolate those instances so they cannot carry out attack against other AWS customer. Now, what's interesting in that pattern, however, is that neither of those infected instances act autonomously. Very often those instances are just part of the bigger botnet network, which is comprised of other nodes which are also affected by this malware. And all those nodes in the botnet, they are steered by so-called command and control center, which are just a couple of servers usually, and they are in control of the bad actor to propagate commands and orders to initiate and launch a new attack against the chosen victim. So as you can see here, interesting part is that communication between infected nodes and command and control center goes over AWS infrastructure. So we can trace back where those C2 servers sit. And that creates opportunity for us to disrupt the orchestration infrastructure. And the tactic here is simple. So we're going to turn around the table and rather just taking defensive position of filtering all the bad traffic that we see, this time we want to discourage the attacker from initiating attack in the first place. So we do that by deploying our network of so-called honeypots, which are just normal-looking instances, which are vulnerable like any other instance. And we purposefully allow those bad actors to infect those instances with malware, obviously in the controlled environment, and that gives us a tons of visibility into what this malware software does, what are the commands for initiating attack it's receiving, and it allows us, most importantly, trace back where those C2 servers are. And as a result, then we work with our partners, with the other hosting companies, where those C servers are sitting, and we provide them with the abuse report saying, hey, there's a C2 server in your network doing all those abusive activities, please take it down, and they would usually do. All right, so until now, I have covered all the things that AWS does to safeguard infrastructure and the services. So these are all this is the same infrastructure and services that you are using to build your applications. However, that doesn't cover all the DDoS risk in the spectrum. And this is the good time to remind everyone that DDoS protection, as any security topic in AWS, falls under so-called shared responsibility model, by which AWS takes responsibility of the security of the cloud, and customer takes the responsibility for security in the cloud. So as we now enter that area of customer responsibility, the key principle you should take with you to remember is that the main thing is to remain well architected. So what does it mean in the context for DDoS for you is that you should embrace, you should build your applications in a scalable way that would allow you to withstand those large volume of traffic coming your way. And the way you do so is by following the best practices and the recommendations that we give you for different application types. So what we tend to do is that we point you to reference architecture for specific application types, which entails and illustrates those best practices and what are the components that we recommend. So here you can see example of a web application reference architecture, which has those components and illustrates some of those best practices. So let me highlight some of them. First one being always as much as you can, use AWS Edge services, because those services, they truly run at global scale. And if you think about it, this is the most basic mitigation you can have, right? Is to respond to the large volume of traffic with the right scale. So let's take CloudFront, for example, in this case, which again is our AWS CDN. It runs over the global footprint of more than 600 locations spread all around the world. And with its built-in mechanism to route and distribute the traffic in different places, it can effectively disperse the traffic coming from DDoS attacks or isolate that traffic. Furthermore, and I will also say here that Amazon CloudFront is origin agnostic, which is a very cool feature of it because it can interact with any publicly available origin of your application. So if parts of your application reside and lives outside of AWS, you can still benefit from all the DDoS controls as your workloads in AWS. And I strongly encourage you to go through all the best practices for this type of architectures by checking our DDoS resiliency white paper, which covers in full those best practices and recommendations for different type of architectures, not just web applications. Okay, so now let's dive into our core security service that you saw in the previous diagram, which is AWS WAF and Shield. So these are the security services which allow you to define those application level mitigations, starting with AWS WAF. So AWS WAF, it's an add-on service designed to add a security layer on top of all AWS managed services that carry HTTP or HTTPS traffic. So you can see what those services are on this slide. AWS WAF seamlessly integrates with those services as it doesn't necessitate any architectural changes on your side. It's more of an attachment to those services, and as the traffic flows in, those services accept that traffic and consult that with WAF, and WAF will decide if those requests or the user behind this request exhibits any malicious activities, or there's no threats detected and that request should be just passed on further upstream. Diving a bit more how AWS works, the basic configuration construct is so-called Web ACL, which is basically a container for all the rules that you define that inspect incoming HTTP requests. Now, each rule, arranged by precedence, consists of matching conditions, which can be combined into more complex statement through logical operators. So, for instance, you can very easily craft a rule which will mandate that any traffic, any request against your administration panel, for example, which we check through URL match, if it doesn't originate from your corporate IP network, which we check through IP check conditions, you're gonna just block it. And so blocking and accept are the terminating actions, but there are other actions available as well that you can assign to the rules, like challenge, or you can even throw a CAPTCHA puzzle just to verify that the client behind those requests is actual human being. Now, lastly, one thing which is very essential is visibility, right? So in order to stay on top of all of those emerging threats and be able to react to the DDoS attacks making an impact on your application, you need a quick access to metrics, into quick access to logs, which will allow you to identify attack vector and distill what is the attack signature. So AWS WAF provides all those things. So as you go about and start working with WAF, you open up WAF console and you see empty web ACL. That can be quite intimidating if you think that you have to develop all those rules all of a sudden by yourself. But fortunately, this is not the case, because there's a long list of so-called managed rules that AWS WAF provides. And those rules are created by security experts, either from AWS or AWS security partners. Those rule sets, all of them contain rules specifically to protect you against some common vulnerabilities and exploit that might exist in your application, or from traffic coming from untrusted sources. Incorporating those rules allow you to build some core protection very quickly and are very convenient to use. And AWS offers also a number of those managed rule sets, which you can also see them on diagrams, some with some additional charge, most of them at no additional charge. But related to the topic of this session, there is a very specific one that I want to highlight, which is Amazon IP reputation list, which is a rule set which aggregates IPs with a track record of malicious-like activities. And this is sourced from the findings and intelligence from AWS Threat Research Team, which is a team that has global overarching visibility over emerging threats and attacks that occurs within AWS estate. So they're in a great position to identify those source IPs that keeps re-engaging into the same type of malicious behaviors over time. So based on the nature of those malicious activities, then we organize those offending IPs into 3 IP reputation lists. One of them specifically referencing to DDoS attacks, which is called AWS Managed IP DDoS list. So this rule collects all the IPs that we see tends to actively engage into DDoS attacks, and we frequently update that list. Because the reality is that all of those bad actors and attackers that initiate those DDoS threats, they tend to use the same infrastructure to run those attacks. So if there's attack kicking in or at the full swing against your application, very likely this infrastructure, the infrastructure that performs that attack, is contained in that rule set. So just turning that on can give you immediate relief. So managed rules, that's a good head start, but certainly shouldn't stop there. And there are other types of rules as well. Specifically, you should create your own rules as well using this very extensive AWS syntax, by which you can define specifically, in the context of your application, what is the scope of allowed and expected requests and what is not. Because you know your application the best, so you know how to define those matching conditions. So you can precisely match against various HTTP components such as headers, cookies, query strings, or even network layer attributes such as IP or source of the country. And those rules can really save the day where you're under DDoS attack that is able to circumvent your default mitigations. And once you identify and isolate attack vector, you can then quickly translate that into AWS WAF custom rule and refer to things like Jaffrey fingerprint or country of origin, which are common attributes which are characteristic for infrastructure running DDoS attack. Now we get into this probably most crucial rule here, which is rate-based rules. As the name suggests, this type of rule allows you to control the request rate coming from a given source of traffic. You do so by defining basically a request threshold over a certain time window, both of which are configurable parameters, by the way. So any request that goes over that threshold will get blocked until the rate of the request drops again below that threshold. Now, as AWS keeps counting those incoming requests for that rule, it does so by aggregating the request from a specific attribute or attribute grouping. And this is what we refer to as aggregation key, which is another configurable setting. So the most classic use here is that you would use aggregation key that equals to the source IP, and you would keep counting those requests for any unique incoming source IP. But this can be misleading and this can be troublesome because you have proxies, because you have not gateways with multiple users, legitimate users, behind the same source IP. So here maybe the better idea is to add those rules and use the custom aggregation key based on the session IDs, if you have a notion of the session ID in your application, by which, and that will give you more distinct, more accurate distinction of the viewer session, and then you can apply more stringent thresholds against the incoming request from the unique individual viewer. Okay, so now as we covered AWS building block, basic building blocks, and how they relate to our DDoS story here, let's move to AWS Shield, which is our DDoS-specific service with one purpose only, and that is to provide you with the means to protect your workloads from the DDoS attack. As a matter of fact, we already touched upon AWS Shield. If you recall that slide that I show you all those mitigations that we run to protect our infrastructure and our services, this is what we refer to as Shield standard, because these are the mitigations that run by default. All of you are using them without any configuration effort, without no additional charge. Very often you wouldn't even know AWS Shield exists because it all happens under the hood. Now, to complement the picture, you should know there's a premium tier of that service called Shield Advanced, which is something you can optionally subscribe to. And as you do, you get several additional features that allows you to enhance your security posture against DDoS and ability to respond to those DDoS attacks. So I'll just name some of those benefits here. First one being you get more enhanced and advanced security against infrastructure and application layer attack. And here I want to stress that out, that it is only when you're a Shield Advanced subscriber that you get directly from Shield additional visibility and mitigation against application layer attacks, and which you wouldn't get as a Shield standard customer. And this is entirely separate from the AWS WAF conversation we had. So one example of this advanced mitigation application layer is so-called Layer 7 auto mitigations, which has been really a game changer for Shield customer, as this rule, what it does, it keeps baselining your applications when you run WAF on it. So for any protected resource by Shield Advanced, we build the baseline that gives us understanding what's your daily patterns, weekly patterns, monthly patterns, and then it allows us to apply this anomaly detection. So if we see that 9 o'clock tomorrow, there's much more traffic than it was yesterday, that can be a sign of DDoS attack that we'll notify you about. And Layer 7 auto mitigation will try out to isolate attack vector, an attack signature, translating that into AWS WAF rule that would place into AWS WAF. But it will only place that once it confirms that it's not going to affect your baseline traffic, which is considered legitimate traffic. So this is one of the features that you can enable, you can opt in, and remember, you have to do it deliberately as well. You also get near-time visibility into DDoS events, so you get all the information as attack takes place and after the attack. What's the attack vector? What are the top talkers? What are the mitigations and their efficacy that are applied? Importantly, you can always reach out to Shield Response Team, which is our team of security experts available to you 24/7 when you're a Shield Advanced subscriber, which is there to mainly restore your application availability if it's impacted by the DDoS attack. So they'll usually jump on a breach review and help you identify what's the vulnerability, what's the attack vector, and translate that into specific mitigation that they would put into Shield systems. But more often, they would translate into WAF rule that they would put in your WAF on your behalf if you authorize them to do so. And the last one I'll mention is also cost protection from scaling activities, as obviously DDoS attack can result in the usage surge on the protected service. And that means also surge on your bill. So after the attack, as a Shield Advanced subscriber, you can also reach out to AWS, asking them to provide the credits for all that excess traffic from the attack that we can attribute to the DDoS event. All right, so we covered a lot of ground. I hope you now have a good background to listen about real-life story from Chetwood Financials, where you can hear what can be consequences of the DDoS attack, what learnings you can get from them, and lastly, how to evolve from that to have consistent DDoS defenses in your organization. So with that, over to you, Sean.
Thank you. Good afternoon, everyone. Thanks for the introduction, Camille. So am I right? Okay. So I'm delighted today to have the opportunity to represent and introduce Chetwood Financial. So who are we? We are a UK-based digital bank, which means that we are very technology focused. We leverage technology to deliver innovative financial products to benefit consumers. Our footprint in the marketplace is growing. We're soon to enter the specialist lending mortgage space this year, and over the next few years we've got ambitious growth plans. So speaking to the other security leaders in the room, being a regulated bank means security is our top priority. But the regulatory landscape is changing. I see that the bar of regulatory standards is rising considerably. We're transitioning from traditional cybersecurity controls and data privacy, data protection, expectations. You know, the regulators are now expecting us to be, to implement a lot more controls around operational and cyber resilience. And to meet those expectations, DDoS and perimeter security is now even more important. And rightly so. So to link a lot of the concepts introduced by Camille earlier, and now to bring to sort of life Chetwood's experience, the short version is that the TLDR, if you wish, is that in our experience, meeting these challenges is far more than just a technology solution. You also need to focus on the people and the processes. You're not going to get there just by, you know, configuring technology and expecting, you know, to get a good security outcome there. So to bring that to life a little bit more, and to really bring to life our experience and our how we met, you know, our sort of approach to meeting, sort of improving our security posture and improving our DDoS protection, I'm going to introduce Harry, that's going to give you a lot more detail. Over to you, Harry.
Thanks, Sean. Hey guys, so my name's Harry. I'm the lead security engineer at Chetwood, and yeah, I'm just going to take you through a period of time at Chetwood today. Around about 18 months ago, and yeah, maybe you can take something from this, one or two things, apply to your own organizations, your own kind of projects. So to get started then, 18 months ago we really had two key challenges. We'd recently just gone through a merger, so now we found ourselves with two separate organizations, two separate sets of OUs, two separate billing accounts, all of that type of stuff. That really meant for us that we had a lack of visibility, really, of what controls were in each organization. So, for example, we knew that we had Shield Advanced in one organization, and then we had WAF in the other side. But we didn't know who was managing these, how effective they really were, or if they were even associated with any resources anyways. This kind of then falls into the second point, in that we had no centralized management of these controls. So again, we didn't know who had put them in place, who was managing them, if they were just wildly out of date, right? So to combat that, we decided to do two things. The first of those was to combine our organizations together. So we did this by replicating the OU structure from the, let's say, org A into org B, and then migrating those accounts across from org to org. This was done so that the controls and guardrails and SCPs applied to org B wouldn't automatically apply to the new accounts. So then any business critical workloads just wouldn't be affected by those additional controls. We could then phase those controls in as we go to make sure that they weren't kind of affecting production, right? The second thing we decided to do was to implement 3 AWS services. So that is Control Tower, Config, and Security Hub. These are not what you would think of as predominantly perimeter security controls, services, sorry. And you're right, they're not. But what they did allow us to do was to get a much greater visibility of the compliance of our resources particularly the resources at the perimeter, like API gateway, load balancers. We could see when we had these resources that weren't associated with a WAF, for instance. This was going great, but unfortunately we then experienced a denial of wallet attack. So the basics of it was a threat actor was able to exploit some business logic in one of our applications that caused us to have a 4 times increased spend in SNS. Usually the scalability and the elasticity of AWS is one of its highlights, right? It's one of its good points. In this scenario, it was a little bit of our downfall. AWS was able to scale to meet the demand of that throughput, of that unauthentic traffic, but our wallet didn't want to pay for that unauthentic traffic, right? As unfortunate as this incident was, it did allow us to really highlight to others in our organization that perimeter security is a priority. We could back this up by showing them the metrics that we had extracted through config and security hub and those services that we put in for that greater visibility. So just some numbers off the back of that. So this incident, the denial of wallet incident, caused us to have a 4 times increased spend in SNS. This was over a period of days, so it wasn't just like a one-time thing. And the threat actor had over 5 attempts via the same vector. This caused us to design and implement this solution. So you can see at the top we have a infrastructure account. So this is a centralized account at the center of like the hub of our hub and spoke model. Within there we have Firewall Manager, and then from Firewall Manager, which is our centralized management, it then allows us to deploy Shield and WAF across all of our member accounts. So we have over 50 member accounts. So the Shield policy is really designed to be hands-off control. It's set up so that its scope is all of our accounts by OU. So whenever an account is newly vended into our organization, it automatically gets Shield. It's also set up to cover all resource types. So any resource that's created automatically gets Shield as well. We went a little bit further and we deployed the prerequisite resources for SRT. So this is just an IAM role that the SRT used to interact with your account when they need to do an investigation for a DDoS attempt, right? The WAF policies are a little bit different. So we have 2 types. We have what we call a base WAF. So this is a WAF that has some of those base level managed rule groups that Camille was talking about earlier. And it's the WAF that we would expect all of our app teams to use just from the get-go. If they find that during their use of this WAF that they're finding some blocks, some weird behavior, we can then build an application-specific WAF. So this would be a WAF that is tailored specifically to that application. This is what we did in the case of the denial of wallet attack. We built a WAF specifically with rules that mitigated that attack. So the rules that we defined, there were 2 types. The first was a header and value style rule. So we were looking for a particular header with a particular value in the request. So we identified this through threat hunting. If that header and value came through, we would then block that traffic. So this was great. This essentially stopped the denial of wallet attack. However, it only stopped that very specific attack vector. To mitigate potentially other attack vectors, we then put in a second rule, which is a rate limiting rule. So you can have a rate limiting rule at a bit of a more higher level than a header and value. So we had this on the whole endpoint, let's say. So let's say you had a sign-up page and you didn't want people to sign up too often. You could rate limit it at a much granular level. Let's say over 100 requests per minute get blocked. We wouldn't expect Shield Advance, a DDoS protection, to kick in at these much smaller scales. So this is where rate limiting really helps us out, because we can have it so that even 1,000 requests a minute over that, we block. And additionally, if the threat actor was to change his vector slightly, maybe he uses a different device or something like that, or a different IP, we still have some mitigation, some compensating control on that endpoint. So this is great. We now have some controls in place, but how do we actually ensure that they're being used by the application teams? Again, Shield Advanced, the Shield policy, largely hands-off control. It auto-remediates itself, right? It attaches to the accounts when they're vended, attaches to the resources. We don't have to do much for that. WAF, again, a little bit different. So for us, when we put these WAFs in place, we had applications that were in the development pipeline and also applications that were already in production, which meant that we really needed two controls in two separate places to, one, stop the tap, stop new applications being built that weren't having a WAF, and then also mop up the applications that had already gone through. So to do this, we put in two controls, the first of which is checkoff on the left. So this is a very slimmed down version of our CI/CD pipeline, or a CI/CD pipeline, and we have checkoff on the left. Checkoff is a policy as code solution. It allows you to apply rules to your infrastructure as code templates to ensure that they are being developed in line with a selection of out-of-the-box best practice rules. We are using this as a quality gate, so before the developers are able to merge code to main branch, they must be compliant with this list of checkoff rules. We went a little bit further though, because checkoff allows you to define your own custom policies, which is what we did. So we defined a policy that not only checks if API gateways or load balancers have a WAF associated with them, it checks if it is associated with the correct WAF, i.e. the WAFs that we had deployed in the previous slide. For anything that had already got to production, we had config in place already. So config acting as a detective control, it identifies those internet-facing endpoints that don't have a WAF. It then outputs that to Security Hub. We then have a human-based assurance process in which a security analyst engages with the application team and helps them to prioritize the association of a WAF with their resources. This would also be the time when an application-specific WAF could be kind of talked about. If they find in their testing that it's causing them blocks, we could then define and create an application-specific WAF to prevent any blocks in production. So by doing this, we have since prevented 2 further denial of wallet attacks via the same vector. After that period of time, we've had no further denial of wallet incidents and a 0 increased net spend. We're also seeing thousands of additional blocks that we weren't seeing before. So this is traffic that we previously deemed as authentic, that now due to these managed rule groups, potentially the reputation style ones, we are now blocking traffic, which is just reducing load, reducing errors, and reducing the need for manual support in that overhead. So we know we've took a really good step in the right direction, but there's always more improvements to be made. One of those improvements that we'd like to make is to migrate more of our DNS to Route 53. So a great feature of Shield Advanced is their proactive engagement. This is when the Shield response team will proactively, of course, investigate any potential DDoS attacks on your environment. They do this via the health checks of Route 53 DNS records. By migrating more of our DNS to Route 53, we can then leverage those health checks more, and they can the SRT can potentially engage before we even know that we're under attack. We'd also like to switch the base WAF to auto-remediation. In this way, it then becomes largely a hands-off control, like Shield Advanced. So we can ensure, we can be pretty sure that any resources deployed throughout any of our accounts have that base WAF as standard. It's then up to the app teams to define their need for an application-specific WAF. And then lastly, not a technical control, but something we are really trying to strive for, is to improve our use of threat modeling. So we have a security champions program, and we'd like to help empower our developers through security knowledge and through threat modeling, so that they'll then be able to not only define the need for their own application-specific WAFs, but they may be able to then build them themselves. It will reduce the need for that security analyst in that assurance process. So that's all I've got for you today. I just wanted to finish on one final note, in that good security posture is achieved through a combination of technology, people, and processes. It's not only achieved by technology alone. Thanks, guys.
Thanks. All right. Thank you, Harry. Thank you, Sean. Thank you for sharing that story. So let's bring it all home now, right, as we're reaching the end of this presentation. So let me just leave you with some of the succinct takeaways that hopefully you'll take with you leaving this session. So to bring it all together, let me reiterate, DDoS protection is a shared responsibility. AWS assumes it's part of that responsibility by putting in place all of those mitigations and defense strategies that operate to protect and safeguard infrastructure and AWS services, the one that used to be their application. But you also have a big role to play in that process, specifically to find the right mitigation at the application layer to improve your DDoS resiliency by design, so your application can scale up. So for that, use AWS Edge Services for scale, use AWS WAF to put those application-specific mitigation in place, and use those DDoS-specific rules. These are your friends. So Amazon IP reputation list, rate limits as well. And if you are a Shield Advanced subscriber, and we recommend that you take a look and consider that for your mission-critical workloads, take advantage of all the features that it offers that we covered, like Shield Layer 7 auto mitigation rules that will insert the rules into WAF for you, so it will vastly improve your way to automate the response to the DDoS attack. Use things like health checks that Harry talked about that really increase our sensitivity to detect those application layer attack, as that gives us the signal that your application is affected when the health check fails. And on the back of that, Shield response team can engage with you proactively, saying, hey, there's DDoS attack we detected, let's work together on sorting that out. And lastly, again, back to the Shadwood story, if you're running a large organization, a lot of accounts, a lot of applications, very common in the cloud, use Firewall Manager to define your security policies at scale and enforce them at scale, at least so you get the view what resources are in compliance of your policies and which are not. And now, take a quick picture of all those resources and do explore them as you wanna dive into any of the specific topics that we talk about. And finally, please DDoS the survey with your feedback. Yeah, I know, I work on that a lot. With that, thank you so much for coming. Appreciate your time and enjoy the rest of the event. Bye.